So we do have a formula to find the number of combinations instead of writing it out like we did in the first video. And that is that the number of combinations of n objects taken r at a time. So like for instance, taking the 4 different letters, that was our n, and we're taking 2 at a time, that's our r, where r is less than or equal to n, is given by NCR is equal to n factorial divided by n minus r factorial times r factorial. So it's really close to our permutation formula. The only difference is that we have this times r factorial tacked on at the very end there on the bottom. So for example, let's say we were trying to find 4C2. The 4 would be your n, 2 would be your r, and so this would equal to 4 factorial over 4 minus 2 factorial times 2 factorial. And then you would simplify that from there. So remember we'll do the parentheses first. So we have 4 factorial over 2 factorial, 2 factorial. And I'm going to break apart this 4 factorial on the top. And I can rewrite that as 4 times 3 times 2 factorial over 2 factorial times 2 times 1. And the reason why I do that is because I see that these factorials cancel. And so I'm left with 4 times 3 on top, which is 12, over 2 times 1, which is 2, which is equal to 6. So let's do some more examples. So here I have 6C2. So 6 is my n, 2 is my r, and so I get 6 factorial over 6 minus 2 factorial times 2 factorial, which is equal to 6 factorial over 4 factorial times 2 factorial. And now I want to be able to get rid of some stuff. So I'm going to break apart the 6 factorial so I can cancel out this 4 factorial. And so I have 6 times 5 times 4 factorial over 4 factorial. And then I'm going to break apart that 2 factorial because it's my smaller one. And I know that that is just equal to 2 times 1. And so I see these cancel out. And I'm left with 6 times 5, which is 30, divided by 2, which is equal to 15. Okay, now here I have 7C7. So my 7, or my n, is actually equal to my r this time. So I have 7 factorial over 7 minus 7 factorial times 7 factorial, which is equal to 7 factorial over 0 factorial times 7 factorial. Now when you remember back to our previous lesson, we learned that 0 factorial is one of those special values, and we learned that 0 factorial is actually just equal to 1. And so this becomes 7 factorial over 1 times 7 factorial, which is just 7 factorial. Here I say I have the same thing on top and bottom, and so anytime I divide something by itself, it's just equal to 1. Okay, let's look at one more example like this. Here I have 13C9, so 13 is my n, so I have 13 factorial over 13 minus r, which is 9, times r. So I have 13 factorial over 4 factorial times 9 factorial. Now I'm going to break apart that 13 factorial enough until I get 9 factorial, because you want to get rid of the bigger number that's on the denominator. So I have 13 times 12 times 11 times 10 times 9 factorial over 4 factorial, which is just equal to 4 times 3 times 2 times 1 times 9 factorial. And so I see my 9 factorials cancel out. And now I have some bigger numbers that I need to multiply. So when I do 13 times 12 times 11 times 10, I get 17,160. 4 times 3 is 12 times 2 is 24. And then when I divide those two numbers, I get 715. Okay, now let's look at a couple of word problems. So here it says you order a sandwich at a restaurant. You can choose 2 sides from a list of 10. How many combinations of side dishes are possible? So first, looking at this, I know it's a combination because we're just choosing 2 side dishes from a list of 8. It doesn't matter what order I'm choosing those 2 side dishes. At the end, I'm just getting those 2 sides when I get my sandwich at this restaurant. So I know this is a combination. And I'm choosing 2 sides from a list of 8. So that means that 2 is my R and 8 is my N, because 8 is the total on the list. 2 is what I'm choosing out. So I can find number combinations here by doing 8C2. I'll choose my formula. That is equal to 8 factorial over 8 minus 2 factorial times 2 factorial. So I get 8 factorial over 6 factorial times 2 factorial. Now I'm going to break apart that 8 to get rid of the 6 factorial. So I have 8 times 7 times 6 factorial over 6 factorial times 2 times 1. And so my 6 factorials cancel out. And I get 56 divided by 2, which is equal to 28 possible combinations. Okay, and then one more. From a standard deck of 52 cards, and how many ways can 5 cards be drawn? So here, again, order doesn't matter. We're just looking to see what ways we can draw 5 cards. Doesn't matter what order we draw those 5 cards. I know this is a combination. And so this is going to be 52C5 because I have 52 total cards and I'm choosing them 5 at a time. And so this is going to equal 52 factorial over 52 minus 5 factorial times 5 factorial. And then 52 minus 5, I get 47 factorial times 5 factorial. And now I'm going to break apart that 52 until I get to 47. So I have 52 times 51 times 50 times 49 times 48 times 47 factorial over 47 factorial times, and I'm going to break apart that 5. 5 times 4 times 3 times 2 times 1. And so I have my 47 factorials that cancel out. Now I need to multiply these other numbers. So I'm going to do 52 times 51 times 50 times 49 times 48. I get 3, 11, 875, 200 over 5 times 4 times 3 times 2 times 1, which is 120. So 311,875,200 divided by 120. I get 2,598,960 ways.